Okay, in this video I'm going to continue on with exercise 4B of the book Fundamental Applied Mathematics. We're on page 104, and the question is 12. It reads, the swimmer is caught in a current which is flowing southwards at 1 meters per second. If the resultant velocity of the swimmer is 2 meters per second in a southeast direction, find the speed of the swimmer relative to the current, correct to 2 decimal places. So the first thing we draw is our y-axis and our x-axis, making our xy or Cartesian plane. Then we draw the vector of the water, and we're told the water is going in a negative j hat direction, like so. We'll say this is VW, and the magnitude of which is equal to 1. Then we're told that the resultant velocity of the swimmer. Now you might be able to read this in a strange way, so you might find it difficult to read this. It means where the swimmer is actually going. So the resultant velocity of the swimmer is actually Vs. So it's the overall result of all the other vectors. And we know, of course, that V sub s means where the swimmer actually went. Alright? And also, just in case you're not convinced with that, it also says we're asked to find the speed of the swimmer relative to the water, which is that. So that means the quantity which we're given is V sub s. Alright? Either way, V sub s is what the swimmer actually does. So we're told they're going this direction at is it southwest or southeast? Southeast, which means this is 45 degrees. The magnitude of V sub s is equal to 2. So if we resolve this into its component unit vectors, we're going to get the following. You're going to get this in the x or the I hat direction and this in the y. So this is going to be V sub s times the cos of 45, and this is V sub s times the sine of 45. V sub s, of course, is 2, and the cos and sine of 45 is equal to 1 over root 2. So both of these turn out to be the following. It turns out to be, we have V sub s sub x is equal to root 2 I hat, and V sub s sub y is equal to negative root 2 j hat, like so. Alright, so let's just go back to our, relative vectors. So VSW is equal to VS minus VW. But we know these two vectors, so VSW is equal to the velocity of the swimmer is equal to root 2 I hat negative root 2 j. And it's minus VW, which was 0 I hat plus, or 0 I hat minus 1 j hat, like so. So VSW is equal to root 2 I hat minus, and it's going to be root 2 minus 1. Is that correct? Or root 2 plus 1? Root 2 minus 1. Now let me confirm this now. So it's going to be negative root 2 plus 1. Yeah, that's that there. So we're going to get VSW is equal to root 2 I hat, and root 2 minus 1 is root 2 minus 1, turns out to be 0.41 j hat. So we want to get the speed, and the speed, of course, is the magnitude of the velocity. So the speed is equal to the square root of root 2 squared plus 1.41 squared. And that turns out to be 1.47. That's correct. So that wasn't too bad at all. So thanks for watching. Please pass it on to your friends and subscribe to my channel.